The Creating Making Lab is a makerspace and model shop for the students in the College of Architecture at the University of Oklahoma. The facility offers an amazing amount of learning opportunities for building, designing, making, and experimentation through digital fabrication, traditional woodworking, and metalworking. Unfortunately, the outside of the building doesn't convey what actually goes on inside. My goal with this project is to create an identity for the space by building an identifying piece for the outside of the building that hints at what can actually be done on the inside. The concept stage started with many different ideas about what this piece should look like, how it will create an identity, and where to place it on or near the building. Once the exterior wall was chosen as the location, I based the size of my design off the city's signage regulation of 48 square feet of surface area. That led me to make it 12 foot long by 4 feet high. After a lot of ideas and deciding on some important elements, I went ahead and made some small scale models of the favorite designs. In wanting to keep identity in the design with the building's location, I decided to integrate a topographic map of OU campus as a main aspect of the design. The map spans campus from the north to the south, and for the sake of orientation, I pinpointed some specific locations. These locations all correlate with the College of Architecture in some way, specifically being Gould Hall, the CML, and the National Weather Center, which houses an experimental green roof for the Division of Landscape Architecture. The contour lines depict a 2D view of the topography, and the locations will be defined through parametric circles surrounding each point. Once the final design was chosen, it was time to get started on production. The panels for the structure are made out of high-density polyethylene, or starboard, which I decided would be far superior on the exterior of the building compared to other options such as plywood or hardwood. Once ordered in, I was able to start on some demo pieces to see how the tools worked with the material and see some parts mocked up at full scale. Hidden behind the topography is written the word create, which symbolizes not only what is done in the shop, but also hints at the overall theme of the College of Architecture to always be creating better communities, cities, and spaces. The backing and lettering will be made out of acrylic so that they are invisible unless hit by the right lighting or backlit at night. I made some small test cuts of the acrylic to make sure it would show through the back when lit. After the demo pieces were made, it was back to finalizing the models in the RhinoCam software and prepping the CNC router for cutting. I made sure to use router bits that were designed for plastic to get the cleanest cuts possible in my material. And then I set up the starboard on the CNC. Once everything was tightened down, it's time to cut. After the first starboard panel was done, I decided to go ahead with the first acrylic panel to make sure everything worked together before moving on. This also gave me the opportunity to try out the lighting at full scale. Panel 1 was a success, so on to the last two panels. The whole design was split into 3 panels, not just for the visual interest, but also because of the physical limitation of only being able to fit certain size pieces on the CNC bed. Each piece took a while to cut, and I think I ended up spending nearly 22 hours total cutting out all the pieces I needed, which meant a lot of shavings to clean up. Connecting the 3 panels are bow tie joints, traditional woodworking joinery methods which show the CML's deep roots in traditional woodworking and fabricating. Each bow tie is made out of bodark, or Osage orange, which is a native tree to Oklahoma. Using these to stitch the panels together also represents the connection of different disciplines working together at the shop and the connections the college creates with the community.
All 6 bow ties are placed in alignment with specific contour lines to connect the contours between each panel.
Once all the panels were cut out and ready to go, I had to get started on the bracket that would be used to mount the sign. I wanted to make sure everything on this project was fully fabricated in the shop, which also gave me the excuse to have some fun in the metals room. After welding the frame together and making sure it fit, the raw steel needed to be coated to prevent rust. As the frame was drying, it was time to start attaching the acrylic lettering to the back of each panel. I started by reinforcing the structure with metal L brackets that would also become the attaching point to the bracket when hung. The acrylic was offset from the panels in the back, using spacers I cut out of the starboard. This allows for easy drainage and a better viewing effect for the lettering. Since the holes were all previously cut on the CNC, all I had to do was line everything up and attach the bolts through the material. At this point, I was ready to get started on the lighting, which I was really excited about. I used waterproof LED strips and I attached them to both the top and bottom of the acrylic using clear silicone to keep them in place. Now it's finally time to start attaching it to the outside. We attached a wooden structure to the wall so that we could lift the bracket up and rest it on something while marking out where each hole would go. This made it easier to stay safe and also accurate before drilling the holes for the wall anchors. Once we had a few anchors in, we were able to get rid of our bracing and tighten the rest of the lag bolts down. With the bracket fully secured, it was time to carry that bad boy outside and mount it. And there it is, a symbol that gives meaning to the place where it stands. With every aspect built inside those walls and an ever-changing mirage effect depending on viewing angles and time of day, the finished piece gives this nondescript exterior a new sense of place.